operator precedence. Okay, now one of the things that we want to look at is how to logically represent an expression or write an expression to get the same output as we intend to get. Now, what I'm trying to say here is the operators that we use in our expressions, there are some that you need to consider them first before the others. Some of the operators that we have, you need to perform their calculations before you continue with other operators within the same expression. Now, operator precedence determines the groupings of terms in an expression, and this affects how an expression is evaluated. Now, you might be familiar with a popular term that we used to say back in senior high school, which is BODMAS. BODMAS is an acronym for bracket of division, multiplication, addition, and subtraction. In certain regions, instead of BODMAS, you may also hear PEDMAS, parentheses, exponent, division, multiplication, addition, and subtraction. You know, when you hear of BODMAS, it tells you that wherever you have brackets, make sure you perform what is in the bracket first. And then if you have any number outside the bracket, now multiply it. If you see division, then you go by the division. And then you look for wherever you have operands that are multiplication operator. And then you evaluate that and then you continue. Now, note these things, that operator precedence determine the grouping of terms in an expression. Now, this operator precedence concept will tell you how you should go about evaluating an expression, and this affects how the expression is evaluated. I'll give you an example and then you can calculate it and tell me the answer you're going to get, and we'll write it as an expression and see what we are going to get to. Now, certain operators have higher precedence than others. For example, the multiplication operator has a higher precedence than the addition operator. So if you have an expression where you have 2 times 5 plus 2 or 2 times 5 plus 3, don't do 5 plus 3 before you multiply it by the 2. You will get a wrong value. Instead, you do the multiplication first. You evaluate the multiplication first before you consider the addition operator. Now, let's try our hands on this. Okay, this is a simple mathematic expression. So if you probably given this, like, or you are going to probably look down upon whatever you type here, but you'll be surprised that the answer that you are going to get. You start with, okay, now we know something about BODMAS, and we say that, okay, now let's evaluate 3 times 7 minus 6 plus 2. And if you go in that direction, you are going to go wrong. Even apply your BODMAS, if you don't take time, the answer that you are going to get might be different from what the computer might get. Okay? Okay. Now, let me give you the answer. By now, I'm sure you have tried calculating it. The answer is 23. The answer is 23. The question is, how come that you had a different answer, right? Or even if you didn't have a different answer, if you had 23, hooray, then it means you were able to apply your BODMAS very well. In the same way, we are looking at this precedence, the operator precedence concept. We are trying to apply to evaluate this kind of expression, and the answer you're supposed to get is 23. Now, let's write this in our code and see what we get. So 3 times 7 minus 6. So from here, I'll type operator precedence, yes, and I'll say C out. 3 times 7 minus 6 plus 2, 6 plus 2 times 5 divided by 4 times 5 divided by 4 and plus 6, and 6 equals to, let me just copy and then paste this here, and del. Okay, and del. Now we print it out and we get 24. Did I miss something in here? Yeah, I think so. Instead of 6 plus 2, I made it 6 plus 3. 6 plus 3. So good. So that means we are going to get a 23. And yes, now we have 23. So 3 times 7 minus 6 plus 2 times 5 divided by 4 plus 6. It's a common basic arithmetic expression, then we are supposed to get 23. But the question is, how come that no matter what you did, you had, 23. Okay, because you tried multiplying 3 by 7, which is supposed to get you 21. You did all of this, and even when you divide, you are supposed to get some decimal value. So what happened that we have even 23? Now let me tell you something. Let's go back and explain this to you. Now, the result here is what we are going to explain. First of all, you need to group them with brackets, okay? Taking into consideration the precedence. Okay, let's just apply the board math that we know here. Before, I'll just show you the precedence that was applied by the compiler. So then we group all of them, the multiplication. That means we have to solve what is inside this before we subtract this, and then we solve what is inside this before we divide it, and then we consider the rest. So this one, 3 times 27 will give us 21, and then we are going to have minus 6 in this bracket. But we need to also evaluate this one, which is 2 times 5, is going to give you 10, and then divided by 4, okay, which is going to be in the outer bracket, plus 6. Now, we need to also do what is in this bracket, the division, before we even try considering the subtraction. Now, when we do 10 divided by 4, we are supposed to get 10 at 2 point certain decimal, okay, 2 point certain decimal. But whenever you are evaluating expressions, okay, and you have two integral values, when you do 10 divided by 2, the compiler will cut off the decimal point. The compiler will cut off the decimal point. We will look at that. If you do 10 divided by 4, which is here, see out 10 divided by 4. Now I'll explain it shortly. Why so? 10 divided by 4. 10 divided by 4 is 2. Instead of having a decimal point, this is because you are performing an integral expression. Okay, we'll come back to that shortly. Don't worry. The compiler sees this as integer, and therefore you are supposed to get an integer result. And even when there is a decimal point, it will cut it off, and then you will get the integral part of the value. This is what we call it implicit casting. We'll look at that. We'll get there very shortly. So you go back to 21 minus 6, and then plus 2, and then plus 6. And we evaluate what is in the bracket. We get 15 plus 2, and then plus 6. And this is how come we get our final answer. We have 17 plus 6, and we have 23. So this is how the compiler is, executing this expression or evaluating this expression to get to the 23. Now you might be wondering, so is the compiler wrong, or it just couldn't perform the calculation since it missed out the decimal point of it? Don't worry, don't be too quick to judge the compiler. When we proceed, you understand certain things that we call evaluating expressions. Now, the operator precedence that we looked at here, this is what the compiler does. Okay. First of all, it considers wherever you have a unary operator. Now, I'll speak about unary operator very soon when we talk about expressions. But unary operators are expressions with one operand. Okay, we'll look at an example for them. So it looks at wherever you have the not, this one negates Boolean expressions, and if you have true, it makes it false. If you have false, it makes it true. And you have the addition here, but this is not just the normal addition that we use here. It is a unary operator, and you have the subtraction here as well. So all these unary operators are considered first in the expressions, or in other words, they are evaluated first before we come to the multiplication, division, and then the modulo. In this order, which is second, that means they're on the same line. Okay, they're in the same line of precedence. And then come to our normal addition and our normal subtraction, which is third. I know that we're talking about basic arithmetic operators, basic arithmetic operators, but it is also important that you know that it belongs to a certain family. Okay, there are other operators, and that is the less than. These are for Boolean expressions and all that. We'll get there very soon. But one thing that we've been using is the assignment operator. That is the last operator that you consider. So anytime you see this operator, it is called an assignment operator. We use it to say that, for instance, in our code, here in the declaration, instead of saying A equals 10, we don't use this for equal sign. In fact, when you want to compare, we use double equal sign, but that is not what the single equal sign means. This means that let's assign 10 to A and 20 to B. That's why it is called an assignment operator. It's not equal to.